Hello, welcome to module 16. Module 16. All right. So in this module, we're going to discuss the concept of continuous integration, which is a mix of doing tests and also do integration at the same time. Okay. So you have learned about testing and you have learned about integration testing. Now we're going to combine them together. So in the past, like in the 80s, we are doing this kind of sequential implementation, test, and integrate. So you create some code, you edit the code, you test it, you edit some more, you test some more, and finally you just release it or you discard it. So everything goes as a sequence, and the software is not so big, so it's not difficult to do this kind of sequential development. However, in 90s, we start to have more complicated methods. So you have one person create code, another person clone the code, and two people might work on the same code at the same time. So they edit the code, one person tests, the other person tests, and this thing keeps going, and they commit to the repo at the end. So everybody works on their own, and the integration will happen when lastly when they commit to the repo. However, in 2000, we start having better software. So we have some centralized version control and even distributed version control. And you can have the concept of branching, forking, so on and so on. And there are tools like GitHub, GitLab, Bitbucket that are now available so that the developers in the big team, 10 people, 20 people, 100 people can work together at the same time. And we have this kind of flow in the Git. So you can have Git flows, which you can have many branches that are doing different things. Each of them can have their own activity at a time, which might occur at the same time as the other branches. And then you have this kind of merging and branching happen all the time. So things start to get very complicated, and we are not sure which of the part here that we're gonna integrate our software. So nowadays we have the newer concept called DevOps. So instead of just develop and operate separately, we kind of mix them together. So you start with the development phase. You do the code, you do the build, which is after you write the code, you start integrating them and you build them to make sure that they can be integrated together. And then you apply the test. If the test passes, you're gonna start releasing the software. So you go to the ops phase. So you start by deploying it, and then you let the software operate. And then you monitor the status of the software. And if you want to make some changes, you come back to the dev phase, and then you go on this infinite loop. Okay. So devs and ops keeps occurring together, and it always go together one after the other. So let me keep a quick recap of what we have learned about unit tests, component tests, integration tests. We are talking about this level now. So you have gone up from the unit test into integration test, which means we're gonna integrate the subsystem that we have and make sure that the interaction or the interfaces between them are correct. So in the old style development, we would do implementation plus unit or component tests. Okay, each of the developer will do their own development and their own unit tests. And then at the end, everybody integrate their code and they do integration tests and system tests. The problem with this is that integration and system tests can take a huge amount of time at the end because you haven't done any integration before. There might be many problems that occur. This kind of big bang integration will have a lot of consequences to fix. So let's talk a bit about unit testing. So unit tests, we call each unit of source code and we test each unit. And the unit tests are usually automated tests, and it creates and run by the software developer to make sure that each unit behaves as intended. And the goal of this unit testing is we want to isolate each part of the program to make sure that each small part of the program is working correctly. You might have heard some of the word called also component test. Usually we call this with unit test interchangeably, but there might be some slight difference in terms of unit testing is more low level. So we are testing specific method or function. However, in the component test, we might go a bit higher into the class level, or the package level, or even into the complete subsystem level. Okay, so component test can be slightly larger than the ordinary unit test. So integration test is the next step where we link the part of the program or the module to make sure that they are functioning together. And then we check that the components are correctly combined and make sure that the interaction among them are correct. So nowadays in modern software development, we need to do integration as soon as possible because with those complex workflow that we have, we need to identify that the module are working together as soon as possible so that we can fix the bugs or the faults as soon as possible as well. So nowadays, we should integrate all the components right from the start. Do not wait for the end. And any of the module that are not yet implemented, we're going to replace it with the mock-ups. So with this, we always have fully integrated version. Even if it works only for the partial functionality, that is okay. And there are many integration approach that we discussed. So we can do top down, we can do bottom up, we can do sandwich, we can do vertical slice or the thread technique that I discussed, which is very similar to the feature oriented technique. And there are other techniques like the risk oriented or the T-shaped one that we didn't discuss. Nowadays, we have a lot of tools and automation is now everything. So the integration test is benefited from automated tools. So integration test now can be automated into the IDE, right? So we can do integration tests very easily on each developer's local development environment. And automation can help us to always have a fully integrated version for each individual workspace first, okay? So every single programmer will have their own fully integrated version. And the developer only commit the change to share with the others when they are sure that it's not gonna break the whole fully working software. Okay. And by doing this kind of automation, we can check whether what happens with the changes from the other people. So you can always see the status of the project at all times. So start with integration per developer. So having a fully integrated version per developer is good, but it doesn't guarantee that this integrated version will work with the other people because the local setting might include many things like the local environment, the configuration, the plugin, so on and so on. So it might work on your machine, but it might not work on the other people machine. So how can we make this to be more general and it goes out of your IDE? So we should try to combine everything, combine the code from everyone. So every file should be combined every day, okay? And we call this a daily build. So if you keep combining the code that you have every day, make sure that they are compiled together, everything is good, and then you try to run a very simple test to make sure that the system is at least working. We call that a smoke test. Okay, that would help us to ensure that at least every single day you have the software that is runnable. Okay, but if you do daily builds, but if you don't do any smoke tests, then it doesn't have very much value because you just know that they can build, but you cannot make sure that it is executable or runnable. However, doing this kind of daily build and smoke test has challenges on its own. When you have a very large software system, for example, like Windows operating system, it is difficult to keep the build fast. So let's say this is a pretty old version of Windows 2000. It has 50 million lines of code. So this is line of code. And this one takes 19 hours just for one build. So that's even more than one night, right? So you cannot finish the build in one single night. Then this kind of large amount of code and the daily build that takes a long time become the challenge on its own. Okay, so however, the companies trying to find something to help alleviate this. They might integrate just some part and let the test run for only those specific parts. But we still keep doing this, the daily build and smoke test, so that the code will be tested twice, right? So first, it's going to be tested on the developer's machine. And the second one is that they're going to also be tested on the daily build system. Then that comes to the modern technique that we are using nowadays called continuous integration, or CI, okay? The definition of CI given by Martin Fowler, which is one of the main prominent software engineers in the world, he says that continuous integration is a software development practice where the members of a team integrate their work frequently, usually integrate at least once a day. Okay, so that follow the concept of the daily build. And each integration will be verified by the automated build, including automated tests, to make sure that integration is okay and identify the errors, fault, failure as soon as possible. Okay, so when you use this concept of CI, many teams has found that it leads to the reduction of the integration problem and allows the team to also develop the software faster. The goals of CI includes, first, we want to discover the bug early on, the shifting left concept. Second, it will have a cohesive team because everybody in the team will know what's going on and they'll know that the state of the software keep increasing by seeing the result of the daily build. When you check the problem early on by doing this kind of CI, you will have a high quality code base at the end. And everybody knows what other people are working on, so you have high project visibility as well. So there are many benefits for doing continuous integration. The result is you get a better quality software, the software is more frequently tested, and now the test become parallel with the development. You don't need to finish the development and then you do the tests, right? So this can go together at the same time. And integration and release are easy and fast because you keep doing incremental building and integration, okay? So how the build process work? So when you check into the repo, when you make a commit, the build will start with a script. So you depend on the build system that you use. If it's Java, it might be Maven or Gradle. If it's other programming language, you might need to build on those specific build system like Makefile for C or other things for the other languages. And the build script is also kept as a part of the repo itself, okay? And then start running the tests, okay? So your unit test will come at this point. The unit test will get executed by this Maven or Gradle script. And then the test also need to keep in the source repo as well. So test goes along with the code. So whatever is not in the repo is considered doesn't exist. If you want it to happen in the repo, then keep it in the repo. And usually we will need to have a dedicated CI server to run this kind of build because sometimes it needs some powerful machine and it needs to be available all the time, okay? And to survey for some of the CI tools that we have, I use this survey from JetBrains, right? So this is a result a little bit old now. It's in 2023, okay? So the tools that the developer are adopting, 76% are source code collaboration tool, but I want to focus on here. So you will see that 45% of the tools that the developer use is continuous integration and continuous delivery tools. Okay. And if we go into the level of the tool, the most popular ones I think nowadays are GitHub Actions and Jenkins. Okay. You also have the GitLab version called the GitLab CI, and then there are Azure DevOps, other Circle CI, so on and so on. Okay, so they have slightly different features, but mostly they do the same thing. They build your system, they run the test, and they report the result to you. Okay, so some of them are free, some of them are not free. So this depends on the infrastructure, the tech stack, and the subscription that you have in the company. By doing this kind of CI, the good thing is that you get the feedback very quick and early on. So the developer will be notified as soon as the build breaks, and then they can fix the problem. So after the build breaks, fixing the problem is the one that has the highest priority. Okay. Also the same for the test. So if the build is successful, but the test failed, the developer needs to fix the code as soon as possible as well. Then the broken build must be fixed. Okay. And we don't need to wait for the build to complete. So we just you cannot just leave the work if the build is not complete. So you might need to wait until you get the result of the build first, because you do this kind of daily build, and if the things goes wrong, then you don't get the final working software at the end. Okay, so don't go home if you break the build. So the 7 principles of CI are the following. You commit early and often. You never commit any broken code. So you need to make sure that you have the fully working code before you make the commit. And when there are build failures, you try to fix it as soon as possible so that you can fail fast and then you come back quicker. There are some metrics that you can measure. So like you can use some static analysis to extract the metrics, the code quality, amount of code duplications, the amount of code coverage, so on and so on. And you can try to build in every target environment that you're gonna deploy the system, Mac OS, Windows, Linux, or you can test on iOS, Android, and so on. And at the end of every build, you're gonna create an artifact. So you were not gonna just build, so you must build and create the artifact, like the executable file, executable app at the end. Okay, so the last thing is the continuous delivery, which we're not gonna cover in this course. Continuous delivery is the next step after CI. So CI makes sure that things are integrated and checked, but CD will extend the CI so that it can automatically deploy and release to the software users. So CD is usually harder because it needs a lot of automation, how to deploy it into the test environment, how to deploy it into the actual production environment. Okay, so many companies now are doing CI, but only a few companies that can actually complete the whole CD pipeline. So, and that's all. So to summarize, we discussed that integration needs to be done early on. And CI is the concept that helps us to do this kind of early integration tests and also early build of the software. And nowadays, the modern software development, we are doing daily build and smoke tests. So make sure that you can have an executable software every single day. With this, we can discover the problem early on and we can fix it as fast as possible. And that's all for this module. See you in the next module.